This is an NP-F battery backplate. I was sent this to review for free. If you wanted to purchase it, it would cost you about $26. They haven't paid me for my review, and my opinions remain my own. So this backplate has a screw here, and the screw is actually installed on the wrong side when it came from the factory. It's supposed to be in like this, and that will allow you to take this guy and attach it to anything with a 1/4x20 mount point. Now, what it is a battery attachment point for a Sony Style NP-F battery, and it has here a D-tap out, and then over here it has a DC 8.4 volt barrel connector out. We have a DC 12 volt connector out on that side. There's a USB-C and a USB-A port on the bottom here. So essentially you can attach this to something with a 1/4x20 either on the side or the back, and then plug your battery in and have a wire going off to power whatever equipment you're needing to power from that battery. Little specification plate here, and it basically says that the USB-A port does 5 volts at up to 3 amps. It says the D-tap port here does 16.8 volts up to 2 amps. This DC port here will do 12 volts at 2 amps, and there's the DC 8 volt port here, which will do DC at up to 5 amps. So I believe that's directly from the battery because it's an 8.4 volt battery natively. And then the USB-C port does 5 volts at 2 amps. So it looks like your USB ports here are basically just 5 volts. And then it steps up the battery voltage to 12 volts or 16.8 with the D-tap port. And then it does basically direct pass-through on this 8.4 volt barrel connector here. Alright, so that battery clicked in very easily. A little button here that lets it release. When I pushed it in, I'm getting lights here. This battery has 3 lights on this little indicator here. Now, on this guy here, it's showing too bright, and I think it's basically too not lit. So there's a little disagreement between is it 50% charged or 75% charged, but it's not fully charged, and both meters agree that it's not fully charged. And this meter on the side does go out after a while. There, so it went out, and to make it come back you basically just tap it, and I believe it's a capacitive touch sensor because I'm not feeling anything actually click, but when I run my finger over that it does light up. So let me plug in a USB-C power delivery type device. It is negotiating. It's got 4 volts, 1.4 amps, charging at 6 watts. That might be because my phone doesn't need much charging, but it's definitely doing USB-C power delivery there. Alright, I have power to the USB-A port. I plug in to a device to the USB-C port. It negotiates, it starts charging it. The USB-A port power's turned off. Now if I unplug the device from the USB-C port, the USB-A port immediately turns back on. Alright, testing the D-tap port, we do have 16.88 volts coming out of it. I don't have any way to test that it can actually provide the full 2 amps there, but I kind of suspect it can. It provided 2 amps out of the USB-C port like it suggested. I expect it can probably step this battery voltage up and provide 2 amps out of that port as well. Alright, I have a cable plugged into the 12 volt port, and it is doing 12.18 volts DC. So I'm plugged into the 8.4 volt port. It's providing 7.29 volts, but that's because I think that's the actual battery voltage here. I'm pretty sure this 8.4 volt port is basically tied directly into the battery because that's the native voltage of the battery. And so that's rated at 5 amps, but it's really going to be whatever your battery can provide. So you can see here, testing the battery directly, I get that exact same 7.29 volts. And I have direct continuity from the center of that barrel connector to this plug here, and from the outside of the barrel connector to this plug here. So that 8.4 volt plug is basically directly connected to the battery. Everything else goes through some type of voltage step up or step down converter. All right, so the weight of this unit, including that little retaining screw, is 2.5 ounces. All right, so if you've standardized on NP-F style batteries and want to use them to power other things, like something that has a USB-C port at 5 volts, for example, or you need, just an easy way to get a barrel connector for 8.4 volts, or, you want a 12 volt supply, this guy will work pretty well for that. It has this D-tap, it's, 16.8 volts, it steps it up, so if you need a low current, like, something that only takes less than 2 amps on the D-tap connector, that'll work for a while. Obviously, if you're taking an 8 volt battery and stepping it up to 16 volts, the amount of time that's going to last is less than if you had a native 16 volt battery. But if you're looking just to power one thing off of a battery, or several lower volt or lower current draw things, this battery backplate will do that. You could theoretically also use this just mounted to your equipment as kind of a secondary battery storage. Even if it's not connected to anything, it'll hold a battery, and then you can take the battery and move it to something else. So it looks pretty reasonable at the price point. I don't like the fact that you have to pick, do I use the USB-C port or do I use the USB-A port? You can't use them both at the same time. I'd prefer to be able to get 5 volts with a shared 2 amps out of the two, to be able to charge maybe 2 small devices at once. But that's the only real limitation I see here, is that these 2 ports, it's either or, and if you plug something in the USB-C port, the USB-A port is shut down.